Good afternoon, students. Today we are going to learn Raults law from chapter 1, solubility of drugs. Before seeing what is Raults law, let us know what are colligative properties. So colligative properties are properties of solution that depend mainly on relative number of particles of solvent and solute molecules and not on the chemical properties of molecules. म्हणजेच colligative properties ह्या अशा properties असतात सोल्युशनच्या की ज्या पार्टिकल्स नंबर ऑफ पार्टिकल्सवर डिपेंड असतात सोल्यूट आणि सॉल्व्हेंटच्या आणि त्यांच्या केमिकल प्रॉपर्टीजवर ते डिपेंड नसतात. म्हणूनच दॅट इज colligative properties are the properties that depend on the number of solute and solvent molecules. Then there are four types of colligative properties. First is lowering of vapor pressure, elevation of boiling point, depression of freezing point and osmotic pressure. We are going to focus on lowering of vapor pressure. Before learning what is lowering of vapor pressure, let us see what is vapor pressure. So the pressure brought about by vapor in equilibrium with its liquid at constant temperature is called vapor pressure. From the given diagram we will know that what is the concept of vapor pressure. मीन्स जेव्हा एखादं लिक्विड आपण हीट करायला सुरुवात करतो तर एका पॉईंटला त्याच्या वेपर्स फॉर्म व्हायला सुरुवात होतात. तर आपण एका कंटेनरला जर वरतून लीड लावलेलं असेल तर जेव्हा लिक्विड आणि वेपर इक्विलिब्रियममध्ये येतात तर ते प्रेशर त्या कंटेनरमध्ये तर ते जे वेपर्स असतात त्या कंटेनरमध्ये प्रेशर एक्झर्ट करतात आणि त्या प्रेशरला वेपर प्रेशर म्हणायचं. Then what is lowering of vapor pressure? Difference between vapor pressure of pure solvent and vapor pressure of solvent from solution is called as lowering of vapor pressure. Now let us see what are the properties of solution that follow Raults law. Solution should be ideal. We have already learned that the ideal solutions follow Raults law. Therefore the solution used must be ideal. Then it is not applicable where solid dissociate in solvent. For example NaCl. Means NaCl get dissociated into N plus and Cl minus when you put it into a solvent. So in such cases it is not applicable. Then not applicable where solid associate in the solvent. Applicable to very dilute solution of non-electrolytes because very dilute solution is equal to an ideal solution. Then in solution solute can be either volatile or non-volatile. Now let us see Raults law. First condition where solution containing non-volatile solute. So in solution containing non-volatile solute, Raults law states that at constant temperature the vapor pressure of solution containing non-volatile solute is proportional to mole fraction of solvent. म्हणजे ह्याच्यामध्ये फक्त ह्याच्यामध्ये नॉन वोलाटाईल सोल्यूट असणारे वोलाटाईल सोल्यूट नसणारे त्यामुळे वेपर प्रेशर ऑफ सोल्युशन इज डायरेक्टली प्रोपोर्शनल टू इट्स मोल फ्रॅक्शन. तर सेकंड स्टेपला जर आपण प्रोपोर्शनलची सेन काढली तर आपण कॉन्स्टंट ॲड करू तर बनेल वेपर प्रेशर ऑफ सोल्युशन इज इक्वल्स टू के इंटू मोल फ्रॅक्शन ऑफ सॉल्वेंट. देन वेपर प्रेशर ऑफ सॉल्वेंट इज इक्वल्स टू पार्शियल वेपर प्रेशर बिकॉज सोल्यूट इज नॉन वोलाटाईल. Therefore we get vapor pressure of solution is equals to K into XA. For binary solutions it is XA plus XB gives 1. As XB is 0 so we will get XA is equals to 1. And P naught A is the vapor pressure of pure solvent that is equals to K. If we put this value in equation 1 we get vapor pressure of solution is equals to vapor pressure of pure constituent into its mole fraction. This was for solution containing non-volatile solute. For solution containing volatile solutes, when solution contain homogeneous mixture of two volatile components A and B, then at equilibrium, vapor pressure of solution is equals to partial vapor pressure of A plus partial vapor pressure of B. Now we know partial vapor pressure of A is equals to vapor pressure of pure constituent A into its mole fraction and same for B. Therefore we get vapor pressure of solution is equals to vapor pressure of pure constituent A into its mole fraction plus vapor pressure of constituent B into its mole fraction. Then let us see what is deviation from Raults law. In real solution there is no uniformity. Greater cohesive forces than adhesive forces or vice versa. Such liquid pair are not ideal solution. They do not follow Raults law over entire range and shows deviation. These are the points where we get deviation from Raults law. There are two types of deviation. First is positive, second is negative. Then when the total vapor pressure is equal to the sum of partial vapor pressure of both constituent, then it is said to be an ideal solution that follow Raults law. Then second condition, when total vapor pressure is less than the sum of partial vapor pressure of both constituents, then it is said to be negative deviation. And the third condition, when total vapor pressure is greater than the sum of partial vapor pressure of both constituents, then it is said to be positive deviation. These are the three types of deviations. Then what are the limitations of Raults law? Then first is real solution and second is nature of solute. Then in real solution, in this solution solute is high and thus intermolecular forces of solute or solute solvent are predominant that slows down escaping of solvent molecule from surface. This causes deviation because it is applicable only to dilute solutions where forces between solute are same as that of solute solvent. म्हणजेच रिअल सोल्युशनमध्ये सोल्यूट जास्त असतं आणि त्यामुळे सोल्यूट इंटरमॉलिक्युलर फोर्सेस जास्त असतात, ज्यामुळे जी एस्केपिंग टेंडन्सी असते सॉल्वेंट्सची ती कमी होऊन जाते, त्यामुळे डेव्हिएशन कॉज होतो, आयदर पॉझिटिव्ह ऑर निगेटिव्ह डेव्हिएशन. व्हेरॅज इन डायल्यूट सोल्युशन फोर्सेस जे असतात सोल्यूट आणि सोल्यूट सॉल्वेंटमधले ते सेम असतात, म्हणून डेव्हिएशन्स कॉज होत नाहीत. And last point is nature of solute. It is applicable to non-volatile solute because volatile solute can contribute for vapor pressure above solution that causes deviation. And the next is not applicable to solute that associate or dissociate. We have already learned or seen example of NaCl that when it is dissolved into the solvent, it get dissociated into N plus and Cl minus. So such solute are not applicable for Raults law, and these are limitations of Raults law. So we have seen what is Raults law, what are colligative properties, then what is lowering of vapor pressure, then what are the properties that follow Raults law, then the Raults law derivation for both volatile solute and non-volatile solute containing solutions, then deviations and limitations. Let us see next point in our next lecture. Until then, thank you.